480/277-volt single-phase subpanel, while not commonly encountered, can be a valuable solution in specific scenarios. Its primary advantage lies in its ability to deliver more power compared to a standard 240-volt single-phase subpanel. This increased power capacity makes it well suited for powering substantial loads such as large motors or air conditioning systems commonly found in commercial or industrial environments. Another significant benefit is its capacity to minimize voltage drop over extended distances. When a subpanel is situated far from the main service panel, the voltage can decrease along the length of the wiring, impacting the performance of connected equipment. The higher voltage of a 480/277-volt system mitigates this effect, ensuring adequate power delivery even at a distance. However, it's essential to acknowledge the drawbacks. Firstly, 480/277-volt single-phase subpanels typically incur a higher cost than their 240-volt counterparts. This cost difference should be factored into the overall project budget. Secondly, finding qualified electricians with expertise in working with 480/277-volt systems can be more challenging. Handling higher voltage systems necessitates specialized knowledge and safety precautions, and not all electricians possess the necessary training and experience. Before deciding to implement a 480/277-volt single-phase subpanel, a thorough evaluation of the advantages and disadvantages is crucial. Consider the specific power requirements of the application, the distance between the main service panel and the subpanel, and the availability of qualified personnel. Let's examine specific instances where a 480/277-volt single-phase subpanel proves advantageous. Firstly, in a workshop setting, powering a large motor often demands significant power. A 480/277-volt subpanel can readily provide the necessary amperage to operate the motor efficiently. Secondly, in large commercial buildings, air conditioning systems consume considerable power. A 480/277-volt subpanel ensures reliable operation of the air conditioning unit, particularly when located far from the main electrical service. Thirdly, warehouses frequently utilize long runs of lighting to illuminate the storage areas. A 480/277-volt subpanel reduces voltage drop along the extended lighting circuit, maintaining consistent brightness throughout the warehouse. In each of these examples, the 480/277-volt single-phase subpanel offers a practical solution for meeting power demands and minimizing voltage drop. The decision to use a 480/277-volt single-phase subpanel also requires careful attention to safety. Firstly, ensure that all electrical work is performed by qualified and licensed electricians who are experienced in working with high-voltage systems. Secondly, adhere to all applicable electrical codes and regulations such as the National Electrical Code or NEC to ensure safe and compliant installation. Thirdly, use appropriate personal protective equipment or PPE such as insulated gloves and safety glasses when working with electrical equipment. Fourthly, to energize the circuit before performing any work on the subpanel or connected equipment. Fifthly, verify the voltage and polarity of the circuit using a reliable voltage tester before commencing any work. Sixthly, properly ground all electrical equipment to prevent electrical shock hazards. Seventhly, label all circuits and components clearly to facilitate future maintenance and troubleshooting. Eighthly, inspect the subpanel and connected equipment regularly for any signs of damage or wear. Ninthly, replace any damaged or worn components promptly to prevent potential hazard. Tenthly, provide adequate ventilation for the subpanel to prevent overheating. Additionally, when planning a 480/277-volt single-phase subpanel installation, consider the following factors. Firstly, determine the appropriate size of the subpanel based on the anticipated load. Secondly, select a subpanel with an adequate number of circuit breakers to accommodate all connected equipment. Thirdly, choose circuit breakers with the correct amperage rating to protect the circuits from overloads. Fourthly, ensure that the subpanel is properly grounded to the building's grounding system. Fifthly, install the subpanel in a location that is accessible for maintenance and troubleshooting. Sixthly, protect the subpanel from physical damage and environmental factors. Seventhly, use appropriate wiring methods and materials that are rated for the voltage and amperage of the system. Eighthly, properly terminate all wiring connections to ensure reliable electrical contact. Ninthly, test the installation thoroughly after completion to verify proper operation and safety. Tenthly, provide clear documentation of the installation, including wiring diagrams and component specifications. When working with 480/277 volts systems, it's crucial to understand the potential hazards and take appropriate precautions. Firstly, always assume that all electrical circuits are energized until proven otherwise. Secondly, never work alone on electrical equipment. Thirdly, use a buddy system to ensure that someone is available to assist in case of an emergency. Fourthly, be aware of the potential for arc flash, which can cause severe burns and other injuries. Fifthly, wear appropriate arc flash protection when working on energized equipment. Sixthly, follow lockout/tagout procedures to prevent accidental energization of equipment during maintenance or repair. Seventhly, be aware of the potential for electric shock and take steps to avoid contact with energized parts. Eighthly, use insulated tools and equipment when working on electrical circuits. Ninthly, maintain a safe working distance from energized equipment. Tenthly, be aware of the potential for electrical fires and take steps to prevent them. Moreover, when selecting components for a 480/277 volt single-phase subpanel, it's important to choose high-quality and reliable products. Firstly, select circuit breakers from a reputable manufacturer that are UL listed or certified by another recognized testing laboratory. Secondly, choose wiring and connectors that are rated for the voltage and amperage of the system and are suitable for the intended environment. Thirdly, use conduit or other protective measures to protect the wiring from physical damage. Fourthly, select a subpanel enclosure that is appropriate for the environment and provides adequate protection for the internal components. Fifthly, use grounding electrodes and conductors that are sized according to the NEC or other applicable electrical codes. Sixthly, choose surge protection devices to protect the equipment from voltage transients and surges. Seventhly, use appropriate labels and markings to identify circuits and components. Eighthly, select components that are easy to install and maintain. Ninthly, choose components that are energy efficient and will help to reduce operating costs. Tenthly, select components that are environmentally friendly and comply with RoHS or other environmental regulations. In addition to the technical aspects of 480/277 volt single-phase subpanels, it's also important to consider the economic implications. Firstly, compare the cost of a 480/277 volt system to the cost of a 240 volt system, taking into account the cost of equipment, installation, and maintenance. Secondly, evaluate the potential energy savings of a 480/277 volt system compared to a 240 volt system. Thirdly, consider the impact of voltage drop on the performance and lifespan of equipment. Fourthly, assess the reliability of the electrical supply and the potential for power outages. Fifthly, factor in the cost of downtime due to electrical problems. Sixthly, consider the potential for future expansion or changes in the electrical load. Seventhly, evaluate the impact of the electrical system on the overall building energy efficiency. Eighthly, consider the potential for rebates or incentives for energy-efficient electrical equipment. Ninthly, factor in the cost of insurance and liability coverage for the electrical system. Tenthly, consider the long-term cost of ownership of the electrical system. Furthermore, when designing and installing a 480/277 volt single-phase subpanel, it's important to consider the specific requirements of the application. Firstly, determine the power requirements of all connected equipment, including the voltage, amperage, and power factor. Secondly, calculate the total load on the subpanel, taking into account the demand factors for different types of equipment. Thirdly, select a subpanel that is sized appropriately for the total load. Fourthly, choose circuit breakers that are rated appropriately for the individual circuits. Fifthly, ensure that the wiring is sized appropriately for the amperage of the circuits. Sixthly, provide adequate ventilation for the subpanel to prevent overheating. Seventhly, protect the subpanel from physical damage and environmental factors. Eighthly, install the subpanel in a location that is accessible for maintenance and troubleshooting. Ninthly, provide clear documentation of the installation, including wiring diagrams and component specifications. Tenthly, test the installation thoroughly after completion to verify proper operation and safety. When troubleshooting a 480/277 volt single-phase subpanel, it's important to follow safe and systematic procedures. Firstly, to energize the circuit before performing any work on the subpanel or connected equipment. Secondly, verify the voltage and polarity of the circuit using a reliable voltage tester. Thirdly, inspect the subpanel and connect equipment for any signs of damage or wear. Fourthly, check the circuit breakers for tripped or blown fuses. Fifthly, use a multimeter to measure the voltage and amperage of the circuits. Sixthly, use a clamp meter to measure the current flowing through the conductors. Seventhly, check the wiring connections for loose or corroded terminals. Eighthly, check the grounding connections for proper continuity. Ninthly, use a thermal imaging camera to identify hot spots or overheating components. Tenthly, consult with a qualified electrician if you are unable to resolve the problem. Keep in mind that working with 480/277 volt systems requires specialized knowledge and experience. If you are not qualified to work on electrical equipment, it's best to consult with a licensed electrician. They can assess the situation, diagnose the problem, and perform the necessary repairs safely and effectively. Proper maintenance of a 480/277 volt single-phase subpanel is essential to ensure its reliable operation and prevent potential problems. Firstly, inspect the subpanel and connected equipment regularly for any signs of damage or wear. Secondly, clean the subpanel enclosure to remove dust and debris. Thirdly, tighten any loose wiring connections. Fourthly, test the circuit breakers periodically to ensure that they are functioning properly. Fifthly, check the grounding connections for proper continuity. Sixthly, lubricate any moving parts, such as circuit breaker handles. Seventhly, replace any damaged or worn components promptly. Eighthly, update the wiring diagrams and component specifications as needed. Ninthly, schedule a professional inspection of the electrical system every few years. Tenthly, keep a record of all maintenance activities. Finally, it's important to stay up to date on the latest electrical codes and regulations. The NEC is updated every 3 years and contains important information about the safe installation and maintenance of electrical systems. Consult with a qualified electrician or electrical inspector to ensure that your electrical system complies with all applicable codes and regulations. By following these guidelines, you can ensure that your 480/277 volt single-phase subpanel is installed and maintained safely and effectively, providing reliable power for your equipment and protecting your property from electrical hazards. Understanding the nuances of 480/277 volt single-phase subpanels is crucial for making informed decisions about electrical systems in commercial and industrial settings. This knowledge empowers you to optimize power distribution, enhance equipment performance, and ensure the safety of your electrical infrastructure.